Good evening. My name is Pradeep Kurup, and I'm the founder of AquaTerrene, a UMass Lowell startup located here at the Innovation Hub. AquaTerrene has developed a novel electronic tongue that can conduct rapid on-site detection of heavy metals such as lead, arsenic, and mercury in water, soil, and sediments. This device is portable, it's lightweight, it's very accurate, and very sensitive. High levels of lead in drinking water, it's well known, can cause irreversible neurological damage and many medical disorders. In fact, the elevated levels of lead in Flint, Michigan, and in Boston public schools have emphasized the need for a rapid on-site testing device for testing water. Existing techniques for heavy metal detection basically involves taking water samples, transporting it to off-site labs, and testing using large, expensive benchtop equipment. And it usually requires a trained personnel, and it takes more than days and even weeks for the test results to come back to the field. And this slows down many site remediation projects. And in fact, it does slow down sending out advisories, drinking water advisories for warning people. AquaTerrene's electronic tongue is basically a handheld device. It uses a disposable electrode which is immersed into a solution of interest, and it has an LCD screen that detects the type of heavy metal and it gives out its concentration in real time. This animation basically shows how the heavy metals are detected. We apply a negative potential to the electrode surface, and the heavy metals basically get reduced to the surface, and then we increase the potential, and one by one the heavy metals get oxidized back into the solution. The potential at which the peak occurs and the magnitude of the peak tells us the type of heavy metal and its concentration. These are the results for lead in water. We can detect lead as low as 10 parts per billion. The EPA action limit is 15 parts per billion. And according to the US EPA, more than 40 million Americans are affected by lead in water. Arsenic is another problem. It occurs naturally in bedrock, and it comes out. Once again, the action limit in this case is 10 ppb, and we can detect arsenic at 5 ppb plus or minus 0.5 ppb. For our business strategy, we plan to use a razor blade business model where the device itself can be purchased for less than $20, and the electrodes, which are consumables, would be sold for $2 a strip. This is just similar to the glucose and glucose meter. We are currently also testing various food matrices, and this is in collaboration with the US Army NATIC. We can detect mercury in fish, arsenic in rice is a big problem, and we can also test lead in various beverages. For environmental site characterization, which is a multi-billion-dollar market, we have integrated the electronic tongue inside a probe that can be lowered into monitoring wells or that can be pushed into sediments for rapid screening of contaminated sites. The competitive advantages of our device are shown in this table. Basically, it's portable. I showed you a handheld model. The probe is also portable. The limits of detection, we can achieve very high sensitivity, that's parts per billion. It's easy to use, very user-friendly, and the device costs less than $100 compared to $100,000 for the large benchtop equipment. Our team from UMass Lowell, you can see here I work with faculty from multiple disciplines and students from multiple disciplines, business advisors, and we are working with partners for field testing our device. We have a US patent pending, and we are funding from the National Science Foundation, the Massachusetts Technology Transfer Center, and the US Army NATIC. Once again, AquaTerrene has developed an electronic tongue that can empower ordinary citizen scientists to test their drinking water. Thank you. I'll be happy to take questions. Yes.
Is the tongue only going to be able to be used in liquid-based devices, or are you going to be able to use these in sediment or gas-based environments?
Okay, so heavy metals in water is the biggest problem. So even if it's groundwater, heavy metals can be bound to soil particles, but what's being consumed is in water. So right now, we can test in the aqueous phase, but in solid phase, we can extract it and test it. So we have methods to extract it from a solid phase and test it. Any other questions?
When do you think it'll be on the market?
We hope to have it in the market very soon. There's a very big need. As I mentioned, not just in the US, it's 40 million. Worldwide, globally, it's a huge problem. And especially arsenic in India and Bangladesh, it's a major problem, lead arsenic. So we would like to get it as early as possible. We have a working prototype. Please visit our booth. It's just below the LCD screen there. And we can show it working. Thank you.
Thank you.